Enter Online, and today we are going to be looking at the area of part of a circle. We are going to start with the area of a circle, area of a sector, area of a segment, and of course the example of each of those three we are going to be looking at. So let's start off with the area of a circle. So how do we find the area of a circle? The area of a circle is given by pi r squared. Pi is a constant, r is the radius of the circle, and of course you can see the distance from OA is the radius of our circle. As an example, let us consider a circle with radius 7, and we are supposed to calculate the area. The area of the circle is going to be equal to, area is equal to pi r squared, which will be equal to 22 over 7 multiplied by 7 multiplied by 7. And if you work this out, you're going to have 154 centimeters squared. Now, apart from that, if we have two radii meeting at a point, they form sectors. So how can we find the area of a sector? Now the area of a sector is going to be a fraction of the whole circle. Now that fraction is going to be, so if we have a circle like this one with a center O, and then we have a radius 1 and another radius 2, then the angle between the two radii is going to be called theta. And if I want to find the area of the minor sector, then we are going to have it as theta over 360 degrees multiplied by the area of a circle, which is pi r squared. So you can see this portion is a fraction of the whole circle. That means if we also want to calculate the area of the major sector, we are going to take 360, we subtract theta, and then multiply it with the area of a circle. As an example, let us find the area of a whose radius is 14 centimeters, and the angle subtended to the circumference is 60 degrees. So of course the area is going to be very easy. That is pi over 3, that is theta divided by 360 multiplied by the area of a circle, which is pi r squared. So theta in this case is 60 degrees divided by 360 degrees multiplied by, you can use pi as 22 over 7, multiply that by 14, multiplied by 14. So let me grab my calculator very quick. Let me have 60 divided by 360, 102.67 centimeters squared. Now, that is it. Now, apart from sectors, we also have segments. And a segment, in our previous video, we explained what a segment is. And today, we want to know how we find the area of a segment. Now, to find the area of a segment, let us consider our circle here with the center O and radius R. And of course, we have two radii meeting at a point and they form an angle. That angle we are going to call it theta. So how do we find the area of the shaded region? In this case, the area of the minor segment. That is what we want to look at. So to find the area of the segment, then we are going to consider two things. The first, we're going to consider a sector. So we have two radii meeting at a point, they form a sector, and those two radii obtain an angle of theta to the circumference. Again, we have a triangle OAB. Now, if we calculate the area of the sector and subtract the area of the triangle, then we are going to have the area of the shaded region, which is, of course, the area of the minor segment. So that means the area of the shaded region, which is a minor segment, is going to be equal to area of the sector minus the area of the triangle. And of course, the area of the sector, we have the area of the sector here, which is theta divided by 360 degrees, multiply that by pi, multiply that by the radius squared, and we subtract the area of the triangle. We have so many formulae to calculating the area of a triangle, and in our preceding videos, we are going to do more about the areas of a triangle, and therefore follow our videos for more about the area of a triangle. But in this case, we can use the formula half multiplied by the first radius, again multiplied by the second radius, and we are going to have radius squared multiplied by the sine of theta. So in this case, you notice that we're going to have r squared and r squared. If we factor out r squared, area of the segment is going to be equal to r squared multiplied by theta over 360 degrees multiplied by pi minus a half sine of theta. So that is the formula for getting the area of the minor segment. As an example, we are supposed to calculate the area of a segment whose radius is 14 centimeters and the angle subtended to the circumference is 70 degrees. And of course, you can see the circle drawn here. We have 70 degrees is the theta, 14 is the radius, and we are supposed to calculate the area of our segment. And we're going to use this formula here because the area of the segment is going to be equal to r squared multiplied that by theta over 360 degrees multiplied by pi multiplied by, we subtract a half sine of theta. So let me just use this rule here. So the area is going to be equal to r squared. R squared is 14 squared. Multiply that by 70 divided by 360 multiplied by pi. You can use 22 over 7. We subtract that half multiplied by the sine of 70 degrees. So let me grab a calculator very fast. Let me do that. So the area is going to be exactly equal to 27.64 centimeters squared. And that is how we can find the area of the segment. So, in summary, this is what we have learned today. We have learned on the area of part of a circle. We began by finding the area of a circle, and we said the area is pi r squared. And then we found the area of a sector. Remember, a sector is formed using the d or the diameters, and its area is a fraction of the circle, which is theta divided by 360, and you multiply that by the area of the circle. You have also looked at the area of a segment, and to find the area of a segment, then you're going to have the area of the sector, and you subtract the area of a triangle. The area of the sector is given here, and the area of a triangle is given there. Of course, we have done an example to illustrate how that is done. So that is it. We are going to do more examples on the same, and in our next video, we are going to also look at the angle properties of a circle and how we can interpret all the angles that are formed within a circle. So see you in the next video. Thank you.